Now we're going to continue looking at the law of cosines and the law of sines in some cases, but we're going to be, again, applying these to some applications or some word problems. And then we'll also be taking a quick look at how to find the area of a non-right triangle. First, we'll look at a baseball example because there's a common misconception I want to point out on this one, or a very frequently made mistake. So when we're looking at this triangle in here, going from home plate to first base over to the pitcher's mound, this angle right here is not a right angle, and a lot of people assume that it is. The reason it's not a right angle is because the pitcher's mound is not exactly halfway between third and first base. So I wish they had kind of moved it forward a little bit more to exaggerate that this is not making a right angle. But what we do have here is that the distance between the bases is 90 feet, and they've given us the distance from home plate to the pitcher's mound, and they've given us the angle in here is 45 degrees. So in this setup, we do have two sides and the angle in between them, which means we can use the law of cosines to solve this third side up here. So here I've shown which formula from the law of cosines I'm using. Since we're looking for side C and we do know angle C, I used this one right here. And then I went ahead and plugged in, they already identified what is angle A, so that means side A is 60.5. What is angle B? So side B is 90. Plugging in the values, if you type this into your calculator, you should have gotten approximately 4,059 0.857. The number goes on and on, but the main thing I wanted to make sure you guys remember to do, this is what C squared equals. So make sure that you take the square root of that number, and that'll give you just C by itself. And then I got approximately 63.7. They didn't say what to round to, so I'm just going to do it to the nearest tenth in this case. So now we know that the distance from first base to the pitcher's mound is 63.7. That's all this question asked for, but there are some other parts that they may ask you for on a math lab or a worksheet assignment. For example, they may ask you the distance from the pitcher's rubber to second base. And I see a lot of people just assume that that distance is also 60.5. But again, remember I told you that this is not making a 45, 45, 90 triangle right here. However, if instead of going from just the pitcher's mound down to home plate, if we went all the way from second base to home and over, this actually would make a 45, 45, 90 because they told us that the sides are 90. And they told us that this is 45 degrees here. And for the sides opposite to be the same, then that means the angles opposite those have to be the same as well, which means that this angle right here must be a right angle. So here you actually do have a 45, 45, 90, which means you could find the distance all the way across by using your special right triangle rules. So it's the leg times root 2 to find the hypotenuse. So the way I would recommend finding the distance from the pitcher's rubber all the way to second base would be to take this entire distance, 90 root 2, and subtract the part of the distance that they gave us here. They told us that this is 60.5, so you can just subtract that decimal, and that'll give you what's left on the other side of the pitcher's mound instead. So one of the best pieces of advice I can give you for a question like this is don't go in assuming anything. A lot of people get questions wrong because they assumed that this triangle here was a right angle, and that wasn't true. I was able to show you why this bigger triangle did have a right angle in it, but on that smaller one, it was not a right angle inside here by the pitcher's mound. You'll see other questions dealing with looking up at a flagpole, and I see a lot of people assume that distances are equal or that they're cutting something in half. So try to avoid any assumptions other than what is given in the question, and you'll be more successful. Before I do the next word problem, I wanted to do a quick review of some angle concepts, especially with compasses on the next slide. But first, I wanted to remind you what angles of elevation and depression look like. So remember that your angle of elevation or depression that they give you, that's always the angle between a diagonal line and a horizontal line. So an angle of elevation, like in this case, that means you have a diagonal line looking up at some object, and I'm saying there's a horizontal line coming out of that same object. So then whatever number they give you, that's what goes in between. Now, the reason I'm trying to remind you of this concept is because you'll have some questions where you have a person on this side looking at an object, often it's a flag, and then you'll have another person on the other side looking up at an object with a different angle of elevation. So then maybe on the other side, they give you an angle of elevation of like 15 degrees. And then typically they tell you how far apart the two people are from each other. So if you connected this all together, this is where our triangle comes from. And they'll give you some distance like all the way across is 500. So the common mistake made on this one is I see a lot of people assume that that means the first person is 250 feet away and the second person is 250 feet away. But since they have different angles of elevation, that actually means that they are not an equal distance from the flag. This is just 500 feet all the way across. It could be that this guy is 100 feet away and this person's 400 feet away. We don't know the exact numbers based on what was given. However, you do have two angles in the triangle, so you should be able to find the angle up here at the top of the flag. And then once you use that setup, you'll have an angle side pair for using law of sines. And then you might want to break it down and look at one of the sides of the triangles here. Doesn't matter whether you use the one on the left or the right, but then you could focus on just the triangle here and turn this into a right triangle, knowing one of the sides so that you can solve for the other pieces if you need. Then you could find how far this guy is from the flagpole, or you can find the height of the flagpole itself. Next topic for review is how do bearings work compared to our math unit circle angles. So remember, the unit circle starts on the right-hand side at 0 degrees, and it measures going around counterclockwise. But the compass, or any bearing-related question, starts from north as 0, and it measures the clockwise amount of rotation. So a couple things I wanted to remind you, because there are different ways they may present the angle information to you. If they just give an angle, they don't have any east, west, south, anything for the cardinal directions on there, then that means starting from north, measure how far they rotated clockwise. So 200 degrees would be approximately down here. So you might need to use that information and combine it with another person who's going straight south, for example. And then you should be able to find the angle in between. If this is 180 and this is 200, then now I know that the angle in between is 20 degrees. So you'll need to think about how the given bearing will relate to some other angle that's given. They have to give you two different ones, and then find the distance between them for filling out your triangle. They may have the bearing described with some combination of west of north or east of south, whatever that case may be. So here, they're not saying to use the numbers as described on the compass going around. They're instead saying start from this direction, so start from north. And then if they say measure 35 degrees west from there, they're telling you how far to rotate in this direction. So then 35 degrees west, which means this would also probably be combined with another object moving straight north. Then now I know that the angle in between would be exactly 35 degrees. So again, this will be one of the pieces of information. They'll have to give you another piece of information as well, another line that you draw out, and you'll have to be able to use the given bearing to find what the angles are inside of your triangle. And then one last one, this is probably the trickiest one. I think you guys are familiar with something like northeast. That's going to cut north and east in half, and it's going to be a 45-degree angle. So no matter which way they extend it, whether you have something going north or something going east, that would make a 45-degree angle. However, this one's a little bit trickier. East-northeast, you might not be as familiar with. It cuts that angle in half again. So you can see it right here, east-northeast. So what I want you to be aware of, if this comes up in a word problem, is that means we're taking the 45-degree angle and we're cutting it in half again closer to the east side, which means that the angle in here would be 22.5 degrees. They could do the same thing by doing north-northeast, in which case then it would be the 45 plus the 22.5 if we're making that angle with an east line instead. So make sure you remember how these bearings relate to a compass, and then see how that will, the given information will fill inside the angles of your triangle. So here's an example using bearings, and in fact, I actually used two different bearing systems. Usually you will only have one system used throughout the question, but different questions will use different systems. But just to avoid doing duplicate examples, I went ahead and did two different bearing systems in the same problem. So what we have here is two boats leaving a port at the same time. So we have a common starting position for the objects. The first boat is sailing 45 miles per hour at a bearing of 55 degrees. So remember, if you're thinking about the compass on the last slide, if we start from north and we're rotating clockwise, 55 degrees should be doing something like this. Then we have a second boat leaving from that starting position, and he's traveling at a bearing of 50 degrees east of south. So it may help to even have a little X and Y axis drawn here. South would be pointing straight down, and they're telling me to go 50 degrees east of that. So in this case, something kind of tricky is happening because the angle they've given me is not the angle inside of the triangle. So we have 50 degrees there. Up here on this side, we had a bearing of 55. That was also not inside of the triangle. So what we need to think about is for this entire half of the unit circle, we know that this would be 180 degrees. So you could do 180 minus the 105, Or you might want to look at it one quadrant at a time. So we have this first angle was 55, which means on the other side of the right angle piece, in between the diagonal and east, then that means you have the extra 35 degrees in there. And for this angle, we have 50 degrees in the bottom, but if this makes a right angle between south and east, then that means on the other side of the diagonal line, we must have 40 degrees. So altogether, what we're ending up with is a triangle that has a combined 75 degrees. So I'm going to redraw that triangle just so that it's a little bit easier to see what's happening here. So I'm adding these two angles together because they're both inside of the triangle. And the question asks, after the boats travel in those two different directions, how far apart will they be? So we're going to be looking from the end of one arrow to the end of the other. Here's another important part of this question. Make sure that you are not putting the speeds as the sides of your triangle. You actually want to use the equation distance equals rate times time to figure out what these distances were. We want distances for the final answer because that's how far apart the boats will be. So we need to have distances on the sides of the boat for the sides of the boats as well. So the first one was traveling 45 miles an hour, and he was traveling for 3 hours. So this is our rate, and this is our time. We're just multiplying those two numbers together. So that means the first length is going to be 135 miles. And the second boat travels for the same amount of time. They left at the same time, but he's traveling at a slower speed. He's only going 30 miles an hour. So here we have 30 miles an hour for 3 hours. If you do rate times time again, now you're getting a side of 90. So here we have two sides and we have the angle in between. You should be able to use the law of cosines here to find that given final length. It doesn't matter how you fill out the sides of the triangle here either, since they didn't make any labeling on their own of saying what's angle A, B, or C. I just went ahead and filled in my own. And then using the formula, you would have that side A squared is going to be equal to 135 squared plus 90 squared minus 2 times 135 times 90 times cosine of 75 degrees. So the answer you should get if you plug all of this in is approximately 141.5. I was trying to highlight more of the angle measurement part here, so I didn't show all the work for this, but make sure you do still get that same answer when you apply the law of cosines formula to the given triangle here. So again, just to recap on the angles over here, you're going to need to be comfortable with how the bearings relate to the angles inside of the triangle you create. So just be careful about which system they've given you and make sure you understand how to use the numbers on a compass to determine the angles. The last part of this lesson is actually pretty straightforward and easy. So we will also find the area of triangles. Now this is not tied to the law of cosines. This is actually a new formula I'm giving you. And there are just 3 different versions of them. But for remembering them, it's pretty easy. It's always 1/2 times 2 of the sides times sine of an angle. And you'll notice that each set of the formula has an A, a B, and a C. So whichever angle you have, it's the other 2 letters for the sides. If you have angle B, then it's side A and side C. So now I'll demonstrate quickly how to find the area of a triangle using one of these setups. So do make sure that you have all 3 letters. We have angle A, which means we needed side B and side C to use the formula. So we're just going to be computing 1/2 and then multiply the 2 sides together. And then whichever angle you have, it should be sine of that angle. Make sure you use the sine function. So this is a pretty straightforward concept. When I typed this into the calculator, I got an answer of 115.8, but it says to round to the nearest square meter. So I would be rounding this to approximately 116. And that's it for the lesson on applications using law of sines and cosines and for finding the area of a non-right triangle. Thank you guys.